Good day. I am Jayman San America, and I'm going to discuss the topics on the sixth week of the fourth quarter. At the end of the lesson, the learner should be able to identify the appropriate rejection region for a given level of significance when the sample size is large enough to invoke the central limit theorem, and to conduct the test hypothesis on a population proportion with a sample size is large enough to invoke the central limit theorem. In decision making, we should always consider projection region. The decision rule can be one of the following possibilities. First, reject the null hypothesis of if z computed is less than the negative of z critical. Otherwise, we fail to reject the null. Second, reject the null hypothesis if z computed is greater than the positive of z critical. Otherwise, we fail to reject the null. And lastly, reject the null hypothesis if the absolute value of z computed is greater than z critical over 2. Otherwise, we fail to reject the null. So, this is the summary and illustration of the decision rule and the rejection region. Okay, so let's have an example using the example on the fifth week of our lesson. The principal of an elementary school believes that this year there will be more students from the school who would pass the national achievement test or not. So the proportion of students who pass the NAT is greater than the proportion obtained in the previous year, which is 0.75. For us to come up with a good decision, we should have an appropriate critical value. For the problem, the second option is the appropriate decision rule. Suppose the level of significance for alpha is set at 0.05, then the decision rule for the problem can be stated as reject null if z computed is greater than z critical of 0.05, which is 1.645. Otherwise, we fail to reject the null. Note that this test procedure is referred to as one-tailed z-test for the population proportion, and the rejection region is illustrated as follows. And for the computation, the third step is to compute the value of the test statistics using a random sample of observation gathered or collected for the purpose of the test hypothesis. Suppose from a simple random sample of 100 students of the school, 78 students were able to pass the NAT. Hence, the computed test statistics is z of c is equal to p hat minus p of 0 all over the square root of p of 0 times the difference between 1 and p of 0 all over n, which is equal to 0.78 minus 0.75 all over the square root of 0.75 times 1 minus 0.75 all over 100, which is equal to 0.692. For our decision and conclusion, in our problem, with the computed value of z statistics equal to 0.6928, the next step is to use the decision rule to make a decision. And our decision is not to reject or fail to reject the null. Why? Because our z statistics or z computed is equal to 0.6928 is less than our z critical of 1.645. Therefore, we should not reject the null. Lastly, as a consequence of the decision, conclusions are made which are in relation to the purpose of the test hypothesis. With the non-rejection of the null hypothesis, then it can be concluded that it is not true that more students of the school did perform better in NAT this year at 5% level of significance. Or we could say that there is no significant difference between the number of students who did perform better in NAT this year and the previous year. Okay? So thank you for watching. God bless and good luck.